Welcome to a new video in my home automation series, and this is something that I started recording a long time ago, and I haven't released the video because there was a few things that I wanted to fix, which is it's this touch panel info screen on the sort of the HMI touch panel that I use to control my home, like my lights and heating and everything else. So because I collect all the data from my EV charging, I wanted to display this data. So if I want to check how much, whether it's charging or not and how much it has charged today or the previous days, I can just quickly go there and then visit this page and I get this information. And it is working pretty much already, except the fact that, as you can see, there are a couple of fields where like stars are displayed instead of the actual value. So I must have done something wrong with the how I transfer the data, and this is why it is not being recognized as a valid data. So it just shows like these stars, which usually means that the value is out of range, but it shouldn't really be. So I need to do some debugging, but I'm always deferring this. So yeah, I will check it at some point, but I thought I just get this video out. And this is going to be a very long format video because I recorded the entire setup. So it's well, it was actually about a 1 hour activity for me to do, and it is it's not complicated, but it's a fairly tedious work because if you have watched my previous video, so I have the data which is coming from the charge controller, so that I capture in Node-RED. So all the information is in Node-RED, and from the Node-RED I push this data to my main PLC over Modbus. So I had to create a bunch of registers in the PLC so I can just upload the data. And then the touch panel pull this data from the PLC because they pull a bunch of other data for, temperatures and lights and everything. So it is communicating with the PLC anyway. So I thought this would be the easiest way to do. And all of these are different systems that they use different applications. So obviously Node-RED is Node-RED. The PLC is a Saia PLC, so they have their own application in order to write programs and then do all the maintenance. So I had to create all the registers there manually. I mean, obviously type them in. And then the HMI or the touch panel is a Riftec touch panel. Again, that has its own application studio where I had to do the whole thing again, like creating all the values, creating the screens, and then just assigning them and telling them what sort of value, what is the data type, and the number of decimals. So this is why it took a long time to do. It's not particularly complicated job, but yeah, it's a little bit of manual work. And also making sure that all the systems are aligned. So if you are interested in this type of stuff, then obviously watch the video. So there is going to be a part where I do the PLC setup to create the new values. I also then do the HMI setup to assign these new values and put them into the various fields. I've created all the fields manually already off the camera because that's more like UI design, so that's not that well important. It's even probably less important than setting up the whole stuff. And then finally, once I had the registers, then I created all the endpoints from Node-RED in order, so once I have the data, I was just pushing them out to the PLC using a Modbus, updating a Modbus register simply. So what I'm displaying on the screen, so I have a few things that I wanted to see. So for example, when the charge is happening, so on the right side, I wanted to show all the current charge information. So what is the voltage, the amps, the power, which is what the charger sees, or actually it's an energy meter just before the charger. So that is the information that I capture and show it on the screen. And then it's also it shows a timer, so how long the charge is going. So you can see the couple of minutes. I recorded only a couple of minutes of clip, so you can see that number increasing. And then I also calculate how much I've charged into the car when it is charging. And then I also summarize this data on a daily basis. So on the sort of the left upper side, I show how much I've charged today in terms of time and kilowatt hours, and how much it was in yesterday in terms of time and kilowatt hours. So again, I can, if I I put it on a charger multiple times a day, then it would just add up. That's simple as that. And also I was interested in how much electricity I used since the beginning of the year, because as I probably mentioned in the previous video, I'm like on a yearly tariff because of my solar panel. So so I will pay that yearly. And that's also like an indication for me just to tell how much I have used. And so you can see that, what is it, like 300 or something kilowatt hours? I can't remember from the top of my head. I don't see the screen at the moment. Maybe I'm just going to leave that, and I'm also going to leave the information how many kilometers I've driven with the car since I had it, because that's pretty much, I think, probably give or take, I don't know, 50 or 60 kilometers, because I didn't have this measurement and logging up and running in the first couple of weeks, which probably could have been, I don't know, like maybe 100 kilometers that I've driven that. So obviously this car is used in the city, just very quick city runs, but also it's a very small vehicle and a very efficient vehicle. So I think the usual kilowatt hours per 100 kilometers or whatever it's measured, it's also fairly low. But you can compare it if you have some similar electric cars. And again, just an added bonus, if the car is charging, then I can see like also a small animation that these arrows indicating like electricity is going from the grid to the car. So that's just a small visual addition that I wanted to add to this screen. So yeah, that's what I'm going to be showing in this video. So if you are interested in details, then stick around for the rest of sort of 45 or 50 minutes. So I'm thinking about where to start, but I think I'm going to start right at the end. Mostly because I've done some design for the touch panel already. So I'm opening the Riftech Studio or RStudio, where I can design my HMI screen. And so this is, well, there's going to be a lot of stuff here in Hungarian, so you have to bear with me. So that's my main screen, and I have already created a screen for the EV screen, and I put all the things that I want. So there's going to be a bunch of data here, which is based on the current, voltage, amps, watts. So that's the power draw or current draw of the car. And then there's going to be like a timer, hour and minute, and the kilowatt hours. So that's what is going on at the moment. And then there is going to be a statistics for the day, statistics for yesterday, and there's going to be finally one which calculates how much power I have used or electricity I have used this year. And that's, I mean, the reason I have this because I want to do, because of some stupid billing that I have at the moment with my electricity company. Okay, so so I have volts, amps, watt, time, kilowatt hours. I just want to take notes. Kilowatt hours, and then today. So today is going to be time and kilowatt hours. Yesterday, and there's going to be time and kilowatt hours, and this year kilowatt hours. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5. Okay, yeah, that's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to have 10 new data that I need to do. And yeah, and there's going to be some animation here. So what I'm going to be doing, as I mentioned previously, is I need to get this data onto the PLC. So the HMI can just, read it from the PLC. If I have multiple HMIs, then it's easier that way. So I think we need this Saia program, and I have my current project loaded already. Oh, and that's not my project. Ooh, that's not one I worked on the last time. So okay, that's it. Um, so I'm not really going to look at the the whole logic, because it's well, I'm not really doing any, I'm not really creating any logic. So all I need is, I need to create a couple of new variables. So I'm going to be focusing up there. So you can see that there I have like, bunch of pages here controlling lights and heating and irrigation and yeah, pumps and stuff. So I think this one is that's my heating control. It's not as complicated, but it has a couple of stuff in it. Okay, so what I want to do is, I'm thinking about what I did. So I had yeah, so I need a couple of registers where I can create, I can store the data. So I need registers because I need to store numbers, so not flags, which would be like the bit ones. So the registers are like, I'm not even sure what data type they are using here, but I think it's like some sort of integer. And I know that these are the ones that I used last time, and so I can see that my the last number that I used. Oops, I should not have done that. So the last register that I created was 1525. So I think I do, yeah, insert. And I think I'm going to call all of them like EV and 1526. I mean, I usually do all of these in Hungarian, but just for the sake of the video, I'm going to use English here. So current charge voltage, and then insert EV current amps. So that's going to be register 1527 current charge amps, EV current. I think I'm just going to, yeah, okay, 1528. Okay, and I think, so I'm just going to make a note here. So this is called this, and it's 26. 1527. 1528. EV current time 29. Okay, and I have a couple of these stats. So insert, so EV today time 1531. I don't really need the names, to be honest, because I would use the register values, but I think I'm going to use the same names in the HMI as well, in the HMI project. 1532. Okay, and then insert yesterday time. I don't know if it does auto numbering, but I never use that. I mean, auto numbering the registers. I mean, if I wouldn't specify, I'm pretty sure it would automatically allocate one, but I want damn it. What do... Nah. Okay, yes. The day, kilowatt hours, register 15. And this is H. Let's be a little bit pedantic about this. EV this year, kilowatt hours, so 1535. This charge kilowatt hours. And because I have 10, so I started with 6 and yeah, okay, so we are good. And then let's save, and that should be it. Okay, so this is all good now. So the only thing which is left is actually load the new program to the PLC, and I can do it. I always forget which one is this, but I think it's this one. Yeah, download program. So download first time initialization data. I know I don't want to clear outputs. I don't want to backup. I don't care. Okay, so connecting. Yeah, I'm okay with that. This will stop. Yeah. First time initialization values has been changed. No, that's fine. Yeah, cool. That was easy. Let's check. It is running. And yeah, things are looking good. Let's check a temperature. Yeah, looks fine. Okay, so that was all about the PLC stuff. Do you want to save changes? Did I change anything? Well, I put a watch, whatever. Okay, so I don't think we need this anymore, but probably I'm just going to keep this open. And now we need to create all these variables here in the address library. Whew, and we are creating stuff here, and I need one of these. So I think I'm just going to do copy, and I start creating all of these. So that's going to be the first, and the value is 1526. Copy and paste doesn't work. And then, yes, we are reading from the PLC, and it is, yeah, this type. I think W means it's like not a bit, but a word or something like that. So there is an EV current volt and and that's it. Okay, let's copy. Yep, and then copy. Copy. Okay, so that's good. Okay, this goes much quicker now. So that's 30. it's going to be 31. Good. And that's 32. 34. Yep. And the final one is 35. So let me just check quickly again. 26, 2, 7, 8, 9, 1, 2, 3, 4, 5, 6, 5. Okay. So these are all the new variables created. So now all we need to do is set these things up, and the only thing I need to figure out is the various decimal places and that sort of stuff. So I think, well, let's start with the voltage. So the voltage is going to be EV current volt, and the number format is, I mean, technically this is never going to be negative, and I think it's I'm not going to have decimal places. So no decimal. Okay, so the current is going to be the amps, and again the number format is unsigned, and I think I'm going to have, yeah, let's say 4 digits. I mean, the integer digit is going to be 2, and I think there's going to be 1 decimal place. Okay, and then this is going to be watts, and I know that this is going to have 2 digits, and I mean, technically it can be 3 as well. Not that it really matters, but that's going to be unsigned as well. Again, it doesn't really matter whether it's 16-bit signed or unsigned, but the one that matters is the number of decimal places. Oh, okay. Okay, so yeah. Would I ever have 100 kilowatt hours charge? No, probably never. But yeah, 32-bit. I mean, a Modbus register is 32 bits anyway, so we might as well just have that. Okay, and then we have this one, which is going to be the time, and the time is going to be in a special format because so that's going to be 16-bit unsigned and 2 decimal places and 2 decimal places, because so I can't, well, I haven't figured out how to display time. So I think what I'm going to do is I'm going to send in the hours as the, you know, hundreds and thousands, and the minutes as tens and ones. And I'm just going to say that, you know, put the decimal, put a point after the second after 2 decimal places. So it's going to be like, you know, hour dot minute. That's the best I can do. Okay, so anyway, that's how it's going to look like. And then we have the key. Oh, sorry. The watts is that's 4 digits. And then the kilowatt hours is going to be, sorry, did I change? Yeah, I did. So this one is kilowatt hours, and then the number format is 32-bit unsigned and 4 decimals and 4 integer digits and 2 decimal points. Oh, okay. So that's 0 decimal and 2 decimals. Okay, and then I will do the rest the same way. So this is today time, which is going to be 2 and 2. So you can see how it's going to look like. And this is today kilowatt hours, which is technically is going to be a 32-bit unsigned 4 and 2. Yeah, it's going to be a little bit small. And today, yep. And then I'm going to have yesterday's as well. Yesterday time, which is 16 unsigned, 2 and 2. So you shouldn't expect a sign. And yesterday kilowatt hours, number format, 4 and 2. And that's going to be the last one. This year number format, unsigned, 4 and 2. And that's it. So from this one, it knows which register to read, and that's it, I think. And I have these errors. So these arrows yeah, so they are going to be animated based on, I think, probably I'm going to use the watts. So if it's 0, then nothing happens, and if it's more than 0, then it's going to like do these animations which go inside, which is this one. So that's status 2. So the red arrows are going to go into, and I'm never going to use status 1. Just checking again. Yep. See, EV current watt. Yep. And technically I have a few of these, so I would need to change for all of these because they are just really, really small animated GIFs, which will work based on these values. I think I have 5 of them. Yeah. We are reading the watts, just to make sure that I'm reusing the same for all of them. This current watt. Okay. I think I have everything that I wanted. I mean, there's nothing really happening here. We are just displaying some values. So I can compile and then see how it looks like. Looks good. I have no errors. So I can download the changes to the HMI and download. And these registers are all 0 at the moment, so I should be seeing a lot of zeros. So you have to bear with me for a moment because I'm going to check this one now. Yeah, I checked, everything is good. So we are good to go. Because now we have the place to store the data, we have the ways to get the data and put it onto the screen. Now we just need to populate the data, and for that we need Node-RED. And the thing is not running at the moment, so I have to do everything blind, and then I would I would obviously check when the car is charging whether all the values are showing correctly. So let me check my EV tab. So first of all, we would need the data, which is basically here. So this is the bit which comes whenever the charger is on. Well, whenever there is changes in the charger. So I think I'm going to do a function node because there's going to be a lot of changes here, and I think I'm not really sure how I'm going to be doing this, but okay. So I'm just going to copy and paste this because it already shows me the how the data looks like. So I'm going to put this one here, and so I need to output the voltage, the current, and the active power. Yeah, we are not really using anything else at the moment. So that's going to be 3, and I want to do 3 outputs. Yep. So, and so I'm just going to read the data into 3 variables, and again, I'm just going to open another example which I've already copied in here. So the one thing I'm not really sure is, well, I guess I just need to test it out, because I'm pretty sure that the voltage is integer and the power is integer, but I'm not really sure about all the others. Oh, because everything goes into influx, I can just look at influx dV. So let's do that quickly. So I need data from my Node-RED, and it's a sensor, and okay. Oh, sorry. Device is called car charger, and I need current, voltage. Let's do voltage first, and then let's do table so I can see the data. What? I said voltage. Looks much better. Okay, so voltage is actually coming in 2 digits, but I don't think I need it. Well, for this screen I don't need digits. So what did I just copy? Okay, so I going to math load floor. So I'm just going to get the voltage like this, and that's going to be fine. So this is the thing which converts the negative values, because the Node-RED Modbus module doesn't really handle the negative values correctly, and I'm guessing it might not be this. I don't know whether it's part of the Modbus standard how you represent negative values, but the way the Saia PLC does it is that if the most significant bit is 1, then it's a negative value. So this is the conversion, but I'm never going to have negative values in any of these, so I don't really need that. And okay, so I have this example as well. Okay, so that was voltage, and then let's check current. So the current actually comes in 2 digits, so that's good. Because then we just need to times it by 100. And the active power, That also comes into digits. So I think I'm just going to, so no decimal, or the current, did you say 1 decimal? Okay, that's going to be 2 decimals now. So I can just go back and then change the values on the HMI. So I don't think I've mentioned this before, but in most cases we don't really handle float values. We just store everything as integers and times them by 10 if you want 1 decimal place, or by 100 if you need 2 decimal places, and then you just tell the HMI where to put the dot. So this is why I'm doing this, times by 100 or times by something. So that's okay. So that was the current, and I want like this because of the active power. I don't want to do anything. So I'm going to return an array because I'm returning 3 values. So the first one is, well, I'm going to be nice. I'm going to specify a topic, although I don't really need to. So this is going to be the voltage, and then the payload is going to be the voltage. So it's just a number which goes through. And then I have the same for current, active power. So that should take care of all of these. And I don't need a comma here. So we are returning 3 values, and then that's done. Okay, so all I need to do now is I need these examples here because so now the payload has the actual value that we want to send out, and I just need to format this to the Modbus format. So the flex write is expecting this JSON where the value is the register value, and we are using FC6, Modbus function 6, which is, I think, the write holding registers, or one of these. So the unit is 1 and the quantity is 1, and then the address is going to be, for the voltage, it's going to be this. Oops. And so that leaves, that's the first output, and then it will go here. And then we'll have the second output, and that is going to be here, and that's the second output, and that's going to be the next. And then we have the third output. And that's 7. 20, oh, sorry, that was 7, so that's 8. Okay, 7. Okay, and this one is going to go into my flex write. So that will send the information off to the PLC. So let's tidy up. Well, that's tidy enough. Okay, so that's going to be the first thing. And yeah, it should be working now. I don't think we are going to see anything, so that's fine. Let's just convert with the rest. So I also need to, yeah. So this is the charge update. So when something is charging, and I just want to remind myself that okay, so that's the charge state variable. Configuration, no, this is the context, and then the charge state, yeah. So what we need here is the energy used, and we need the time, which I'm going to use this one. So I think what I'm going to do here is, well, I'm going to use something very similar. So charge update, Here you go. And I think I only need 2 outputs. And the first one is going to be charge time msec. And we are going to convert this later on. But I just want to get the values out that I'm going to use. So this actually, I mean, I do remember that this sends through the very same object, which is getting stored in a flow. So that's going to be the message payload. So I need the charge time msec, and I need energy used. Energy used. And that's going to be energy used. Oh yeah, and this is two fixed 2 times 100. Okay, because this is a bool value, I can use the 2 fixed and number prototype 2 fixed. Okay. And then times 100 because we need 2 decimal places. So that's going to be 2.95 because it gets rounded. And time and energy. Okay, we don't need any of the other things, and we are going to output 2. Oops, that's too much. So the second one is definitely going to be this one. So that's good. For the first, we need to do the conversion. So let me just cheat because I am going to get... so I have something here which is... I need the minutes and the hours. Oh, okay, I need these 3. Okay, so it divides it by 1000 to get the seconds, divides it by 60, yeah, okay. And then, so it's going to be time, and that's going to be hours times 100 plus minutes. Yep. I almost could have done this with a expression. And I need these 3 guys. And I need 31 and 32. Okay, so that takes care of the current things. And the next one that I need is this one. Okay, so that's going to give me these. No, actually, I only need the yesterday one. And then I can plug it in here because that's the next day update. Yeah, okay, that looks good. So let's do this, and then do that, and then. So that's going to be, it's going to look like this because this one outputs the EV. Yeah, message of payload is EV. So that outputs the EV, and I need the yesterday. So I think I do some housekeeping here because One sec. So I need to cater for scenarios where the where there is no statistics for yesterday. And I think on these cases, let's just look at the code, because I think in that case the yesterday, okay, then the yesterday would not the object itself is it wouldn't exist, because I'm deleting the EV yesterday here. So I think yeah, so if message dot payload dot yesterday equals undefined. So if it's not undefined, then it's going to be message.payload dot yeah, yesterday dot charge time millisecond, and then that's going to be yesterday dot energy used dot toFixed 2 times 100. Okay, so that's charge time, that's energy used. Okay, yeah, we can't create this again. And okay, actually I need to put this one here as well. So the charge time, yeah, these are all going to be zeros. Okay. Okay, I needed to do this because of the scope, because obviously I'm going to use the information here, because if there is nothing for yesterday, I want these values to be zeroed out. So the time is still hours times minutes, and the energy used is still energy used. So that's good. And then the things that we want to is 33 and 34. So that's 33. And that's 34. And then it goes to the Modbus to update. Okay, that looks good. So, so the only thing is this, the last one that I need is how much energy I've used today. Oh, sorry, this year. Well, not this year, but since the last build meter reading. Which is usually the beginning of the year. So that's why I said this year. And I've already have a fairly big flux query for that. And yeah, it's really interesting. So I'm going to show you this one. This is going to take some time. So what I did is, actually it is fairly similar to what I used in the past as well. So yeah, let's take this one. So first of all, I go to my meter readings. I look at the electricity meter reading. I look at the one which says billing yes, and I get the last one. So as I said, it's always the beginning of the year. Well, it's usually around the 8th of January. So on 8th of January, this was my last reading. So 5125. Okay, well, actually, I don't care what the reading is. I just want to get the time. So from this, I get a, well, because it returns a few, it returns a table stream with a few tables. I actually, well, all of them have the same values, because so these are 3 meter readings that I read from the various meters. So obviously they have the same timestamp, but I only need one. So I just select, I just filter on one, which says off peak, and I get the record 0, which you need to do this, but it's always going to be one record, because we are using last as well. And I'm not going to put this one into the query because it's it won't be able to return it. Oh, sorry, it won't be able to view this on in the Explorer. But anyway, this is what it does. So I just copy and pasted this because it's easier to switch between all tab than switching between the tabs in Chrome. So I got the last build meter reading, and basically I just and I put it into this build thing. It's table, and because I want to use the build underscore time, so you can see the 8th of January. And I want to use this as the range for the next selection, in which I look at the reading for my my first reading after that time. So if I copy and paste this, so now you can see that the first reading from the car charger, so this is the SDM120 energy meter. So the first reading after the 8th of January, that was 9th of January, and that was the reading. So basically I know that that's when that energy meter started at sort of the same time when I had the last build meter reading. I don't know how to explain this. I don't know if you get it, but basically I have two energy meters, and I'm using the ones that I reported the electricity company, and I use the time for that, and I use the time to query all the other data source. So I know that I started the year with 157.61. So that's good. And I can also do another selection where I look at the last the last reading, which is like happened just a few, I don't know, maybe a few minutes ago. So if I do this, oh, okay, I need to delete this so we can test it. So the last one is 288.98, and you can see that today is the 1st of April. It's not April Fool's. And it was like, I don't know, a couple of hours ago at 5:12. Then that was the meter reading. So I know how much I used since the beginning of the year. And I can join these two tables together. And by the way, you can see it here that I added this function, which for both of the tables I'm using the map function to add a new field, which is called the join, and I add a value of 1. Because when you want to join two tables, I mean, even though each table has one single record, so it will be very straightforward to join them, but actually you have to join them based on a common field value. So both of them has the join 1, so I can use this to join the two together, so you can see the first reading and the last reading as well. And with a simple map function, I can easily create a difference. So I can see that I have used 131.37 kilowatt hours since the beginning of the year. And I can just do some housekeeping and then hide all the other date fields that I don't need. So I have the beginning, the end, and the difference as well. So that's the information that I put into a Flux query. So you can see this one is here. So, and I'm planning to run this every every 2 hours. So I think it's going to be every 2 hours. So it's going to query it, and then we get the data. So again, I added these two lines. So first of all, I check if the output from the Flux query is, oh, by the way, I can show you this one because that's already working. So if I trigger it now, oh, I need to deploy. Okay. So if I trigger it now, you can see that this is the information that comes back. So it was a single line here in the query. So we are getting an array with one value, and you can see, you know, value first, value last, and the usage. So I am checking whether I get an array back, and if the array has one line, because let's say if it has 0 line, that means that probably I'm missing some data and couldn't run the selection. And I'm just doing the same conversion as I did last time. So I'm just getting rid of the actually I think it actually makes sense to keep all the values. So what I'm going, how did we configure this? Oh, this year, I think, yeah, we do everything which is kilowatt hours we put, so everything which is everything which is kilowatt hours we put to decimal places. So all I want to do is times by 100. And by the way, I'm not sure if I need to use this, because well, no, I don't know. I mean, technically, if it's always going to be 2 decimal places, so it doesn't really make a difference if I do a math floor or if I don't, because there's not going to be any decimals. But anyway, let's do this, and I probably have to change the others as well. And then we do the Modbus thing as well, and this is going to be that one. And it can go. I just left this as test. Okay, so everything is running now. None of these send any data because the car is not charging at the moment, but I think I should be able to see this 131.37. So I'm going to check it now. So, all looking good. For this one, the yesterday, I mean, it is showing a funny value, but I think I'm just going to wait for it until tomorrow morning, because I don't think I have any data, any real data at all. And by the way, I wonder if I can just do, so if I go online on the PLC, I wonder if I can look at the data, because I'm not really sure if I can, you know, I can do like the magnifying glass up here, but I don't know if I can do the same with these values. So I think they are alphabetical, so I should be, Jesus, where is the EV stuff? I have a couple of data points. Yep. It has 0 value. Yeah, 131.37. Yeah, and all of the others are 0. Okay, so let's look at the HMI project again, because one of them was not looking good. And I think I need to do the kilowatt hour fields a little bit longer, because if I have, I'm just thinking if it's likely that I would reach 1000 kilowatt hours. Well, for the whole year, it's possible. So I think I need to make this field, this one, just a little, well, yeah, it's just going to fit. Okay, so for the amps, we said that we need 2. Okay, so that's it. So now it has 2 decimals. So basically either 0 decimals or 2 decimals. And I think this one's showing EV yesterday kilowatt hours 42. Yeah, looks good. I'm just checking the 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So all looks good. And I think I use the same ones as well. So yeah, anyway, I'm just going to wait until tomorrow, until I have some real data, and I'm going to check all the fields with, with some real data, just to make sure that they are displaying something which is correct. Okay, just going to write this really small change to the PLC, sorry, to the HMI. But I think that should be it. So yeah, it's late, but I think probably I don't know, the car might start charging slightly bit later today. So I'm going to check it, and I'm probably just going to create a recording. I don't know, maybe sometime tomorrow, so you can see the end result on the screen. But yeah, that should be all. I mean, it wasn't really complicated, but it's a lot of copy and paste between, creating variables here and then creating variables here, because obviously it's the HMI is from one company, so it has a program to edit the HMI. The PLC is from another company, so the only common between the two of them, that both of them talk in Modbus. So the HMI can read the registers of the PLC, but then you just have to create everything together and then just make sure that the register numbers match. Yeah, I mean, what we have done is that you have seen the register numbers here. So these are the register numbers, and we just map them to, I think, holding registers on, I always forget whether it's the holding or input registers, but I think it's the holding registers on the Modbus interface. So whatever number I see here, it's the same register number in Modbus as well. It just makes the life a little bit easier. We could have translated it into a different number range, but obviously that would be just more complicated. So at least that makes my life a little bit easier. But other than that, it's like, yeah, it's like UI stuff, and then, moving stuff around, and then, making it pretty, and, switching the fonts. There is so many things that you can do here. So I just spent a little bit of time designing one of them to be, look half decent, and yeah, I just do copy and paste. And that's it. There's a lot of stuff here that you can do, a lot of customization, but I don't really use most of it. So, but I think that should be enough for today. So I hope you found this interesting, or maybe you even managed to learn something new today. But that will be all for today. Thanks for watching, and hopefully see you next video.